This is the Masking Handbook for Audiometry. In this video, we'll be looking at 70 dB interaural attenuation and how this allows an increase of masking via the optimized method. Let's take a look. Using insert earphones, we have normal hearing in the right ear and unmasked air conduction testing in the left. That shows at least a moderately severe hearing loss being present. The unmasked bone conduction threshold in the left ear is 0 dB. We don't know which ear this is coming from. It could be either ear. Let's take a look at our known possible minimum interaural attenuation values for insert earphones. At 1000 Hz, it's 55 dB. When we compare this min IA value to the situation, we see that the difference between the unmasked air conduction threshold in the left ear and the threshold at 1000 Hz in the right exceeds this minimum possible IA. When we ask ourselves the question, am I certain I'm testing the ear I want to test? The answer is no. I can't be 100% certain because it is possible the signal could have crossed to the opposite right side. So we'll need to mask this one. We can use the plateau method for masking in any masking situation. If we adopted this method here, our initial masking level might be something like 15 dB. But the optimized method is designed for asymmetrical hearing losses, and this is a robustly asymmetrical situation. As a comparison, let's determine the initial masking level with the optimized method. A 70 dB value for the test ear level of the threshold. We subtract 10 dB and end up with a 60 dB IML. Quite a difference compared to the plateau method. So we'll deliver 60 dB of narrowband noise to the non-test ear, right ear, and proceed with retesting. Hold on just a second. Didn't I just say that 55 dB was our min IA value? 60 dB is above that. Doesn't that mean that we're at risk of overmasking here? The answer is no. A min IA value is a minimum possible value. The actual IA value is likely to be greater than the min IA. Here we have an airbone gap of 70 dB. Based on the situation, we'll stake a claim on a new IA value. A more realistic IA value for this situation would have to be at least 70 dB. After introducing the 60 dB noise and retesting, we see the threshold has now come in at 90 dB, a shift of 20. The optimized method protocol guides us to now increase the masking by the amount that this threshold has shifted. Since the threshold shifted 20 dB, we will increase the masking by 20 dB and retest. We now have a total masking level of 80 dB. When we retest in this case, the threshold has remained stable at 90 dB. We have a properly masked air conduction threshold at 1000 Hz in the left ear. Final masking level was 80 dB. Hold on again. 80 dB must be too much masking. How can you prove that it didn't cross over and cause overmasking? Well, we have an airbone gap of 90 dB here, and if the IA was less than 90 dB, then such an airbone gap would not be possible. As Turner has observed, an airbone gap cannot be greater than the IA, although it can, of course, be less. In other words, the IA cannot be less than the value of an airbone gap. Hold on again. That's an unmasked bone conduction threshold, which could be coming from the right ear. It's not possible to know if it's a true airbone gap, and therefore we can't make a claim to know about the IA situation. Regarding bone conduction in the left ear, there are two possibilities for the unmasked bone conduction measurement at 1000 Hz. It's either an accurate measure of bone conduction hearing in the left ear, or it's not. If it is an accurate measure, then we know the IA must be at least 90 dB. Let's take a look and see what happens if it's not an accurate measure. The true bone conduction threshold must therefore be worse than 0 dB. Let's say it's 10 dB. Then we now have a SIT IA value of 80 dB. 80 dB IA is still enough to prevent the masking noise from crossing over. Let's now say the true bone conduction threshold of the left ear is 20 dB. Would have a SIT IA value of 70. That means it's now possible that 10 dB of narrowband noise might cross to our test ear side. Will it cause overmasking? No, because as the bone conduction value gets worse, it allows for more and more masking noise to cross over to the test ear side without causing overmasking. Even though poorer bone conduction results means less possible IA, it also means that masking noise crossing to the test ear will not cause overmasking. over masking. The lower the bone conduction threshold, the greater the SIT-IA value, and the less masking crossover. The poorer the bone conduction threshold, the less the SIT-IA, but more crossover of masking noise is acceptable. 30 dB would mean that would have a possible air-bone gap of 60, so 20 dB of masking noise might cross based on a SIT-IA value of 60. But 20 dB of cross-masking noise wouldn't be heard by such a test ear and therefore wouldn't cause overmasking. Besides, we've already established that our SIT-IA for this case, using insert phones at 1000 Hz, must be at least 70 dB, purely from our unmasked test results. This is the Masking Handbook for Audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.